Hi, we are going to talk about transformations of piecewise functions. Now, all of the piecewise functions in the book I noticed were absolute value functions in this section. So we're basically going to go from there. Okay. And what we're going to do, which we've done transformations before. And what I love about transformations is it doesn't matter if it's a piecewise function, a linear function, a quadratic function. It's once you remember these rules, it's the same for all of them. So that's what's really nice. Okay. So in the first section here it's referring to the parent function. And what I did is I drew an example of the parent function in all of these. So then we're just going to basically move the parent function. Okay. If you look at the bottom here, I wrote this equation because this is used very often. All right, so A is always on the outside, H is right here, and K is there. And so if I refer to A, H, and K, this isn't just for my example. This is typically what you will see used. Okay, so at the top, if I have a number outside of the absolute value sign, it tells me up and down. All right, and that letter that's called K. So if I add K to the outside of the absolute value sign, I go up and down. All right, and it's exactly what you think. So this is the parent function, and if I add K or add 3 to the absolute value sign, then I'm just going to shift this, and maybe I should put this in another color. Here, see if you can see this, hopefully. You're going to go up 3 units. So it would end up being above. I don't know if you can see that too well. Do it in pencil. Okay, because you're going to go up 3. So let's next to it, I'm going to write up 3. All right, then down, once again, now it's a negative. So now we're going down 2 units. We're moving the parent function down 2 units, put down 2. So all of this stuff is not too hard. It's just a memorization game. All right, you got to remember up and down. Okay. So now this is called H. If we have H and this is inside the absolute value sign, the way that I remember that is if it's inside the absolute value sign, it's like something's on the sides of it. I have to move it sideways. Shake it up. It's the opposite to what you think. Okay. So here, when we have a plus 3, we're actually going to be moving left 3. All right. So I'm going to move left 3. And then here, something's on the side of it, so I go sideways. I'm going to go right 5. All right, so that's H. Now looking down here, these are when you have coefficients, numbers on the outside of the absolute value sign, and they are going to tell us to do a vertical stretch or a shrink. And we talked about those earlier. If this number is smaller than 1, if it's smaller than 1 and still positive, so you ignore the positive or negative sign for a minute. If it's smaller than 1, it tells you it's going to be a compression, which means it's going to go flatter. It's going to go out like, whoa, not there. It's going to go like here. All right. And if it is larger than 1, it's going to stretch up like this. Okay. Now, if it's a negative, what's going to happen here is it's going to reflect. And it's going to reflect over the x-axis. So let's make sure we write down what we just did. So this was smaller than 1, but larger than 0. So what did we do? We had a compression, and you can just write a compression of a half. Here we had a stretch of 4 because that number was a 4, and here it reflected. Now I'm used to just saying reflect, but I noticed just in case they ask, reflect over the x-axis because it did flip right over the x-axis. Okay. All right, and then here I just wrote the same thing out again. A means it's a stretch or compression. So if we're doing something to the A, you know you're going to say it's a stretch or a compression, and it can reflect because that negative can also be part of the A. If A is negative, it reflects. The H is telling me up and down. Sorry, the H is telling me right and left, and the K is telling me up and down. Okay, like I'm never gonna say to you, hey, what does K do? But a lot of times in the instructions, it might say, how did K affect this, or how did H affect this? And I don't want you to be flustered by it. I want you to say, oh, okay, that doesn't matter so much. It's just where it's located. All right, so you don't have to memorize K moves it up or down. I just wanted to point it out. All right, now I find for these problems here, we're gonna look at this very top part. It says find the vertex. And what I think the easiest way to do this is for me to I'm not gonna actually graph anything. I'm just gonna have a piece of graph paper handy because I wanna show you what my thinking is. All right, I'm gonna draw. And so sometimes, like, I don't need a lot of graph paper for this. I know what the parent function looks like. The parent function looks like this, right? It's going in, the slope is 1, 1, the whole -1. All right, so here is my parent function, and I'm gonna try to find out where the vertex is. The vertex is this point right here. Well, if it's -2, what does that mean? That means I'm gonna move it down 2. So if I take this vertex and move it down 2, well, now the vertex is right here at 0, -2. So see how I didn't draw the whole thing? I just said, here's the vertex, I'm gonna move it down 2, because I'm gonna keep that same sheet, this same parent function right here, and I'm gonna talk about this one. Well, what does this mean? It's in the absolute value sign, so it's going sideways. It's the opposite to what I think, so it's going left 5. 1, 2, 3, 4, 5. Well, here is gonna be where the vertex is. Well, that's -5, 0. So without having to graph it, I'm able to just picture and figure out where the vertex goes. All right, now we have a few things going on in the next one. This says, okay, so what's this doing? And the order doesn't matter so much. So this says I'm taking the vertex and it's going down 1, and then the 3 is saying it's going left 3. 1, 2, 3. So where's my vertex? At -3, -1. Now I wanted to point this out. Remember, this stuff over here doesn't really move my vertex. This just tells me that these lines are going to get skinnier. So my vertex is staying the same. If it reflects, my vertex is staying the same. So this part up here, this A is not even affecting my vertex at all. So if I just look here, well, what would this do? This is gonna go, because it's in the absolute value sign, it tells me right or left, and it's going to go right 1. So even though it goes right 1, the lines get skinnier and it reflects, the only thing that's moving the vertex is that -1 there, okay? So where is my vertex? -1, 0. Okay, same thing, a lot of stuff happening here. So what do we have going on? I like to start from the back, but so this is telling me it's going up 3, 1, 2, 3. This is telling me it's going right 2, 1, 2. Okay, it's getting wider, doesn't affect it. So here is my vertex. This is 2, 3. So not a whole lot of work, but just having this parent function here on graph paper is really helping me figure out where the vertex is gonna go. Okay, what transformations have taken place? So now I'm just gonna say, oh, it's a stretch, a compression, up, down, those are gonna be my answers here. Well, it's not moving up, it's not moving down or left or right. What is this doing? It's reflecting. And that's because of the negative right here. It's reflecting, and I'm gonna say over the X, but I don't really mind if you don't put that. So it's reflecting, and it has a vertical stretch. I can just put stretch of 2. All right, let's look at this one. This is going down 1. Remember, this order does not matter. Down 1, left 3, compression of a half. Over here, reflect, up 5. So we kind of just saw a little robot saying, what do these mean again? Okay, right here, up 2, whoops. Right, sorry, I was going right, left, it's the opposite to what I think. Right one, compression of a third. All right, now what they want us to do in this last part, write the equation. So now it's like backwards. Now it's telling me what's happening and I have to write the equation, okay? I didn't write in the instructions, but we're gonna use g of x. So we're gonna say g of x equals. So here's the parent function. And then what am I going to do to it? Okay, go up 2 and right 3. Well, so there's no reflecting, no vertical stretch or compression, so I don't have to worry about that. I can start with my absolute value sign. I know that x is going to go in it. Well, right and left goes inside the absolute value sign. It's the opposite to what I think, so it's going to be -3. Up is outside, +2. All right, let's do another one. Reflect and then down 1. Okay, g of x equals, I know I'm going to put a negative here, absolute value sign of x, and then going down 1 is -1. The last one, left 4 and a compression of a half. G of x equals, well, remember left and right goes inside my parentheses, compression goes in front of it, and I don't have any reflecting going on. So I have a half, and then I have my parentheses, x, and then left 4 is actually +4. Okay, so none of this is tricky, but if you do have to reserve yourself some time to go, okay, let me just memorize it. This means up, this means down, left, right, compression, stretch. I always love these problems because once I have that memorized, like I said, it works for other functions, and it's pretty easy for me to do. So just have to take the time to memorize it. All right, talk to you guys later. Bye.